Okay, now this is October, November 2020, S1 A-level Maths, component 5.3. Question number 1. The times taken to swim 100 meters by members of a swimming club, large swimming club, have a normal distribution with mean of 62 seconds and standard deviation of 5 seconds. Both of these are given in seconds, 62 seconds and standard deviation of 5 seconds. Find the probability that a randomly chosen member of the club takes between 55 and 66 seconds to swim 100 meters. So we have this as normal distribution, as the question says, with the mean of 62 seconds and standard deviation. So standard deviation squared as the variance. We have to find the probability of x being between the two given values, which is a 56 and 66 seconds. So we have to work out the probability for this. Find the probability between these two. So the first thing we do is we standardize this. So we have Z 56 minus the mean value, which is 62, upon the standard deviation, which is just 5. Then we have 66 minus 62 upon 5. And we get this as negative 1.2 and 0.8. These are the two values we get. Once we have this, this is again like we have minus a z between b. So for this we do pi of b minus 1 minus pi of a. So we're going to apply this over here. So this becomes phi of 0.8 minus 1 minus pi of 1.2. Now we have to look up the value for 0.8 and 1.2. So if we go to the normal distribution table, we have 0.8 as 0.7881 right over here, 0.8 as 0.7881, and we have 1.2 as 0.8849. So these are the two values, this one and this, the yellow ones that we are going to use. So for 0.8, we got the value from the table as 0.7881 minus 1, and this minus, we've opened the bracket, minus becomes plus. For 1.2, we were getting 0.8849. We add them up and the final answer is 0.673 as the final answer. So now we move on to part B. 13% of the members of the club take more than t minutes. Now this is not t seconds, this is t minutes to swim 100 meters, find the value of t. So once we are doing this, we have to keep this in mind that this is in minutes. So for more than t minutes, this is going to be x is greater than 60 times t, because we have the standard deviation and the mean both in seconds. So whatever the number of minutes we get, we multiply that by seconds and we get the whole units as seconds. It's because the whole question is given in seconds, the standard deviation and the mean. So we have to work out the probability that x is greater than 60t is equal to 0.13, as it says over here, 13%. So once we standardize this, we get this as z being greater than 60t minus 62 upon 5. That's equal to 0.13. Now for a greater value, we have probability of z being greater than a we do 1 minus 5 of a, and we can do 1 minus 5 of a because this is greater than and this is less than 0.5. So once we do 1 minus 5 of 0.13, so we subtract 1 from 0.13, we will get 0.87, which we can look up in the table as an inverse of 5, which is greater than 0.5, so it works. So that means this doesn't have to be a negative value, so this works for us. Now this is going to be 1 minus, like we said, phi of all of this. So this is phi of all of this, 1 minus phi of this, which is 60t minus 62 divided by 5 is equal to 0.13. So if we shift 1 on this side, or we shift this on this side, we get 1 minus 0.13. That gives us 0.87. So basically phi of 60t minus 62 over 5 is equal to 0.87. And now 0.87 we have to look up in the table as inverse of phi. So 0.87, we go over here. 0.87, this is the green one. This is the closest we can get to 0.87. Remember, we are looking for 0.87. So this is 0.8686. Now this is 0.8708, the next value right over here. So we have to go a value before that. So what can we add to 0.8686? We can add 14 to this and we'll get exactly 0.87. So that gives us, if we read this from the table, this is 1.1, 2, and 7. So this is 1.1, 2 from this column, 1.1 row, 2 column, and then 7 from this. So that's 1.127. So that's 1.127 we got for this phi inverse. So now this is 60t minus 62 over 5 is equal to 1.127. Now we solve this for t. So we cross multiply this 5 over here. We get this as 60t is equal to 1.127 multiplied by 5. And we bring the minus 62 on this side, so that becomes plus 62. And we get 60t is equal to, what value do we get? We get 67.635. So t is equal to 67.635 divided by 60, and we get t as 1.127, which is 1.13, correct to 3 significant figures. And that is our answer to the second.